we're going to see the topic on correlation. Okay, so in first part we learned that curve fitting. So fitting a straight line, fitting a parabola, fitting a power curve. Okay, exponential curve, second degree polynomial, all those things we saw that. And coming to second part, here it is having we have correlation and regressions. So this is the second part of your fourth unit. Okay, so here it is having, before going to correlation, we'll see that what is meant by univariate and bivariate. So in the name only itself, univariate is nothing but, here it is having, if we discuss about only one variable, then we call that is a univariate. And bivariate is nothing but, it is involving two variables. Okay, so that only here we are discussing about a distribution involving two variables is known as bivariate distribution. Okay, so two variables and it is involving, okay, a distribution which is involving two variables, then we are calling as bivariate distribution. Why? Because variate in the sense variables. Okay, so plural we are using for bivariate distributions. If these two variables vary such that change in one variable affects the change in the other variable, the variables are said to be correlated. Correlated is nothing but relation between the variables. It means that if two variables we are saying here, if these two variables vary such that change in one variable, if it is one variable changes, obviously it shows effect on another variable, then we say that those two variables are correlated. If it is in the sense, if your age is increasing, obviously in your height and in your weight also it increases, right? So in the, here it is height and weight, we can say that height and weight of a particular person, we can say that correlated. Okay, so based on the height, actually weight has to be done. So of course nowadays not like that, but generally what we'll say that is based on age, height as well as weight. So there it is having three variables are nothing but age, height and weight. Here it is we are discussing about two variables, and those two variables, when we'll say that correlated, if one variable any changes are happening, so obviously another variable changes also going on, then we say that those two variables are said to be correlated. So that one, here it is simply we said, if these two variables vary such that change in one variable affect the change in another variable. So suppose if we are saying the examples here, what we said, there exists some relationship between the height and weight of a person, right? So obviously generally what we'll say that if you are growing, okay, obviously for a height, if it is having 6 feet, he has to be 75 kgs. For like that measurements we have, okay, generally not like that nowadays, but generally what we'll say that based on the height, we'll say that the weight. Okay, if it is having 5 feet, he has to be below 60, and if it is having 4 feet, so below like this. For age, based on the age, and we'll say that the height and weight of a person. In the same way, price of a commodity and its demand. Okay, so based on the commodities, okay, price, based on the price it demands. Okay, if price is increasing, obviously demand also may be reduced, or if it, price is decreasing and demand also reducing, like that. And rainfall and production of rice maximum. So rainfall and production of rice is nothing but, so based on the rainfall, the rice will produce that particular field. Okay, so based on the rainfall, that rice will produce. Okay, so the all will say that correlated. Okay, and next in the same way, another simply definition we are saying here, the correlation is a statistical tool which studies the relation between two variables. So correlation means generally what we are saying, it is a relationship between two variables. Okay, so then if two variables are related, then we'll say that that is nothing but correlation. Okay, so and correlation analysis is nothing but involves various methods and techniques used for studying and measuring the extent of the relation between the two variables, analyzing of that relation. Okay, so correlation means just relation between the variables, whatever the variables you are saying. Correlation analysis is nothing but analyzing that relationship. Okay, so analyzing that relationship by using various methods and techniques or tools we are using, that is nothing but correlation analysis. And the measure of correlation, so measurements, so like as mean, variance of what we calculated there in probability, in the same way here it is measurements if you are calculating for that relation. Okay, so if you are finding the coefficient like as, then we'll say that that is correlation coefficient or correlation index. We'll say that the measure of correlation is called the correlation coefficient or correlation index. So total three terminology we are using here: correlation, correlation analysis, and correlation coefficient. Correlation is nothing but, which is a tool is used for finding the relationship between two variables. That is nothing but what we are calling correlation. And correlation analysis is nothing but, after writing the relation, we are using different techniques and different methods we are using. That is nothing but correlation analysis. And next, correlation coefficient is nothing but, for the correlation what we are writing the correlation, if you are measurement, if you are calculating measurements for that correlation, simply we are calling it that is correlation coefficient. Okay, this is about correlation, correlation analysis, and correlation coefficient. And next, types of correlation. So different, we are saying the relation, and here it is we are discussing about different types. So what are those types of correlation? Here it is, there are three important ways of classifying correlation. What is positive and negative, and simple, partial, multiple, and total, linear and non-linear. Okay, so here it is three different types of correlations we are discussing. One is positive and negative correlation, simple correlation, partial correlation, multiple correlation, and total correlation. And next one, linear correlation and non-linear correlation. So what is meant by positive correlation? So positive correlation in the sense, if you are we are saying about correlation is nothing but two variables, right? If the positive correlation in the sense, both the things are going in a same direction or positive direction. Okay, it is nothing but, if it is going like as, simply we'll say that if you are taking as a height and weight, we said, right? So based on that height and weight also going on the same way. Okay, so both are having the equal weight, then we'll say that that is nothing but positive direction. And negative correlation is nothing but opposite. It means if it is, suppose one is increasing, another one is decreasing, it means if you are taking a person and that person height is increasing but weight is decreasing, or weight is increasing, height is decreasing. And that one also, another one also, price is increasing, demand is refusing, or demand is increasing but price is reducing. So opposite. Okay, and next, in the same way, rainfall and production of rice. So too much rainfall and rice is less, and rainfall is less, rice will reduce, rice will sorry, rainfall is sufficient, then obviously rice also will get sufficient. So if it is increases, and obviously rice also reduces, right? So rainfall increases, rice reduces, rainfall decreases, rice also decreases, that is not coming under negative one. So that is the one. Positive correlation and negative correlation is nothing but, so positive correlation is nothing but, if it is any variable is increasing, another variable also same, it shows effect on the same thing on another variable, it means it is increasing, and that one second one also increasing, or first one decreasing, obviously second one also should be decreases, then we'll say that that is positive correlation. And negative correlation is nothing but, one is increasing, another one is decreasing, or one is decreasing, another one is increasing, so opposite directions. So opposite directions, then we'll say that negative one. And positive direction, positive way in the sense, both are having in the same way. Okay, so both are in increasing or both are in decreasing, but negative opposite, one is increases, another one is decreases, one is decreases, another one is increases. That is positive and negative correlation. And next, simple correlation, partial correlation, multiple correlation, and total correlation. Simple correlation is nothing but, if we are discussing about the variables only two, simple, so that is simple correlation. Okay, if you are discussing about only two things, and simple example we can say that if you are discussing about only wife and husband, that is simple family. Okay, small family, only two things we are discussing here, wife and husband, that is nothing but simple correlation. Okay, and multiple correlation, so multiple correlation is nothing but grandfather, grandmother, next wife, husband, next children's, their children's, that is multiple variables. Okay, so if you are discussing about only two variables, that is one we calling as simple correlation. And multiple correlation is nothing but if we are discussing about more than two variables, then we call that is multiple correlation. And partial correlation is nothing but not discussing about all the variables except some variables we excused. Okay, it means if we are taking entire family, in that we are discussing about only father and wife, uh, husband and wife, and we are leaving rest of all the people, that is nothing but partial. So we are not taking all the variables, we are taking only few variables. Okay, that is partial correlation. And total correlation is nothing but entire mottam. Okay, overall, so overall family, each and individual we are discussing, that is nothing but total correlation. Clear about it? Simple is nothing but only discussing about two variables. Partial correlation is nothing but except some variables we discuss about only few variables. It means dependent we'll discuss, and we don't discuss about more than one independent. Okay, so we discuss only few dependent and more than not one independent. And multiple in the sense we discuss about more than two variables. Okay, so 3, 4, 5 number of variables we discuss about that, that is we will say that multiple correlation. And next, total correlation is nothing but we discuss about the entire whatever included in that, all those things if we are discussing, that one we call as total correlation. And next, third one, linear and non-linear correlation. So linear and non-linear correlation is nothing but if the ratio of that variable is going on constant way, then we call that is a linear correlation. And non-linear is nothing but obviously not same ratio. Okay, suppose if we are taking the variables, here it is having x, y variables we are taking. So x variable I chosen as well as y variable I chosen. So x I chosen here 1, 2, 3, 4, 5, 6 and so on. In the same way, if I am taking y values are here it is having 5, 10, 15, 20, 25 and 30. So like that I am taking. Okay, so then is it having linear or non-linear? Linear. Why? Because if you see that the first variable x, really here it is having equal ratio, so the difference is only 1. And next, if you are taking y variable also, the ratio is same. So here it is having 5, 5, and here also 5, and here also 5. That is linear. It is going on a constant ratio. Okay, and non-linear is nothing but suppose here it is having 4, at least one also no problem. Here it is having 3, but here it is having rest of all things are 2. So for that, that is not a non-linear. So these are the three different types of correlation we are discussing. So what we said, positive correlation is nothing but increasing in same way and decreasing also same. So it means dependent, independent both. And a simple example, if wife and husband are going on is simple. Okay, so only one way. Okay, so both are having the ideas are equal, same, then we'll say that positive. When it will be negative, when it will be negative in the sense one is saying as high and another one is saying as low. Okay, so one is accepting, another one is disaccepting, not accepting that, then obviously that is negative. Okay, and simple is nothing but we discuss only about two variables, that is simple. And if we are discussing about more than two variables, that is multiple. Partial is nothing but we don't discuss about all the variables what in that included in correlation, we exclude some variables, that is nothing but partial. And a total correlation is nothing but how many variables included in that, we have to discuss about all the variables, that is nothing but total. And linear and non-linear correlation is nothing but linear correlation is nothing but the variables having the ratio must be constant, it doesn't changes anything. So and in non-linear is nothing but it doesn't equal. Okay, that is linear and non-linear coefficient correlation. So that one we'll see here or in theoretical way what they give. So here it is having first one, positive and negative correlation. So what we said, positive correlation is nothing but it is increasing in one variable is increasing, obviously another variable also must be increases. Or if one variable is decreasing, obviously another variable also decreasing, then we'll say that that is positive correlation, and negative correlation is nothing but one is increasing, another one is decreasing, or one is decreasing, another one is increasing. That is negative correlation. Okay, so that one only we said here. See that if the values of the two variables deviate in the same direction, that is if the increasing the values of the one variable results on an average in a corresponding increase in the values of the other variable. So that only know here it is what is happening. It is increasing the values of the one variable results on an average in a corresponding increasing the values of the other variable. It means one variable values are increasing, obviously another variable values also must be increases. Or if a decrease in the values of one variable results on an average in a corresponding decrease in the values of the other variable. So what we discussed that one or not? So one is increasing, obviously the corresponding value of y also must be increases. One is decreases, another corresponding value of y, that one also should be decreases. Then we say that that correlation is direct correlation or positive correlation. Let us see the examples of this one. These are the few examples for positive correlation. The correlation between the height and weight of a person. Okay, so height to weight equal increase or decrease. Okay, so if you are taking a person, if the height is increases as well as with the along with the weight. Okay, so height to weight rendu increasing. Next are decreasing. Okay, decreasing in the sense decreasing undadu. So height to weight, so increasing one, right? So increasing and decreasing after certain age. Okay, so decreasing in the sense weight only, not height. Okay, so one is higher, that is coming under that time negative also. Okay, so height is increasing, weight decreasing. Okay, next rainfall and production of rice, that is also. So and when rain is sufficient along with the rice. Okay, so both are having the same equality. Okay, so then we'll say that that is positive, are both are decreasing. Okay, rise as well as rainfall. Next, price and supply of a commodity. So if you are taking commodity one, so price, as the price is increasing and supply also increasing, or price is reducing and supply is decreasing, then we say that that is relation is a positive correlation or direct correlation. And next, the family income and expenditure on luxury items. It means that if we are taking a family on luxury items, income is increasing and expenditure also increasing, that is positive. Okay, so income is increasing and expenditure is increasing. Okay, our income is decreasing, expenditures also decreases, right? So based on that income only will do the expenditures generally, right? So if you are getting 10,000, with that 10,000 only we'll do the expenses. Okay, if you are getting 1 lakh, with 1 lakh only we'll do the expenses. Okay, are based on that. So positive only that one. So rendu same amount, increasing, increasing, decreasing, decreasing. Same examples you can choose for negative or the negative also. Why? Because income is increasing but expenditure is decreasing. Oh, sorry, income is decreasing but expenditure is increasing. So opposite only, no. Price and supply also. Okay, price is increasing but supply is reducing. Okay, so those all things simply will say that that is for positive direction. If two variables constantly deviate in the opposite directions, what we said, that is if the increase in one variable results in a corresponding decrease in the other, or if the decrease in one variable results in corresponding increasing in the other, the correlation is said to be inverse or negative. Okay, so inverse or negative, opposite. So one is increasing, another one is decreasing, or one is decreasing and another one is increasing. Okay, so income is increasing, expenditure is decreasing. Okay, sorry, income is reducing, expenditure is increasing, opposite not. Okay, that is, these are the few examples for that. Price and demand of a commodity. Okay, so based on price is increasing and demand is reducing. Okay, volume and pressure of a perfect gas, and sale of woolen garments and the day temperature. Okay, so day temperature also we will say that that is, so it means obviously no. So morning temperature may vary and evening temperature may vary. Okay, so that is going to dark, then temperature also reduces, then that is coming under positive. But that that weather is going to be dark, temperature also reducing, then it is negative, then it is positive. Okay, so that is coming also coming under this positive and negative directions. Okay, so in other words, we can also say that simple example, when you are going to higher semester, your backlogs also is reducing. Okay, backlog, no backlogs. Okay, then we'll say that is positive. Negative in the sense, semester is going on, backlogs also going on, that is positive. Backlogs was reducing, that is negative. Okay, opposite down. Okay, next, simple, partial, multiple, and total correlation. So what we said, simple correlation is nothing but if only two variables are considered for correlation analysis, it is called a simple correlation. Only two variables. If we are discussing about only two variables, then we are saying that is nothing but simple correlation. So that is what we are saying, quantity of money and price level. Okay, quantity of money and price level, only two variables. What about those two variables here? Price and money, quantity of money. And here it is demand and price, only two things. What are those? Demand and price. Next, in multiple correlation, three or more variables are studied simultaneously. So at a time we'll study more than three variables. Then we'll say that there is multiple correlation, like as age, height, weight. Okay, age marks study. Okay, next age, job, next to the circuit, weight, like that. So more than three. So more than two, if we are discussing that, then it may call it as multiple correlation. That may be two variables or that may be three variables also. Okay, next one, that is the same. Here it is, the study of relationship between the yield of rice per hectare and both the amount of rainfall and the usage of fertilizers is a multiple correlation. So total three things here. What are those? Rainfall, fertilizers, and price. Okay, so total three things are. So if you are taking a hectare, okay, so per hectare if you are taking that, so rainfall as well as fertilizers both are having related, right? So if you are producing a rice, what we require? So fertilizers we require as well as rainfall also required. Okay, so total we are discussing about three things. Rainfall, rice is equal rainfall plus fertilizers, right? So rice is equal rainfall plus fertilizers. Okay, so rainfall is one variable, rice is one variable, and fertilizers is one variable. Here dependent is nothing but what? Dependent is dependent. Which one dependent? Which one dependent? Here it is, rice is dependent, or fertilizers are dependent, or rainfall is dependent. Rice is dependent on rainfall and fertilizers. Okay, so that is nothing but, you can choose y is nothing but rice and x is nothing but fertilizer and rainfall, and those two are independent one. Okay, next, when three or more variables are involved in correlation analysis, the correlation between the dependent variable and only one particular independent variable is called partial correlation. It means what we are saying. So partial correlation is nothing but, we are discussing about what we said previous example. That one only you can choose. Here it is. What we are saying here, it is having rice is equal fertilizers plus rainfall, right? So here it is, these two are independent, right? Fertilizer is independent and rainfall also independent. Is it depend on anything, rainfall? No. And fertilizers also not dependent. These two are independent and rice is dependent. So generally if you are writing as y is equal x plus z, suppose x plus z, or simply we can write this one, z is equal to x plus y, z is equal x plus y, like this we can write the relation. So here it is, what we said, multiple correlation means we are discussing about dependent as well as both independent. So what are the independent? Here it is having rainfall and fertilizers both are independent one, and rice is a dependent one. So we are discussing about complete one in multiple correlation. But in partial correlation, we are not discussing about total independent, how many are there in the relation. We are discussing about only one thing. It means suppose rice is equal rainfall, I am saying. I am not discussing about what? Fertilizer. I am discussing about only rainfall and rice. I am not discussing about fertilizers. Or we are discussing about rice and fertilizers, not about rainfall. Then we'll say that that is partial correlation. Okay, multiple correlation means whatever included in that we have to discuss all those things. That is multiple correlation. But in partial correlation, we discuss about dependent variable and only one particular independent variable. Okay, so we are not discussing about all the independent variables in partial correlation. That one we are saying here partial correlation. Okay, let us say example for that. So the yield of rice is related with the application of fertilizers and the rainfall. Generally we are saying what we said. Suppose we can treat as yield of rice is nothing but Z and fertilizers is nothing but X and rainfall is nothing but Y. So the relation is between these two is nothing but simply what we are writing, Z is equal X plus Y. So rice is equal fertilizers plus rainfall. The relation of yield to fertilizers excluding the effect of rainfall. So it means I am discussing about only fertilizers. I am not discussing about the rainfall. So fertilizers is enough for getting rice. No need of rainfall. I am not the effect of rainfall. I am not discussing. Then that is we will say that partial or the relation of yield to rainfall excluding the effect of uses of fertilizers or partial correlations. It means I am not discussing about fertilizers. I am discussing about only rainfall. Okay, then we'll say that that is those are partial correlations. And next total correlation is nothing but what we are saying. If we are considering all the facts what we are taking, so all the facts if we are taking that one, then we are saying that one total correlation. How many include in that? If you are taking your family, your mother, father, children, each and everyone, if you are discussing, then we'll say that that is nothing but total correlation. Okay, clear about it? Simple, partial, linear, multiple, and total. Okay, and next one, linear and non-linear correlation. So the correlation between two variables is said to be linear if corresponding to a unit change in one variable. Just what we discussed the example there is a constant change in the other variable over the entire range of the values. It means whatever the values they gave, here it is. If you see that x values they gave and y values they gave, here x values the range is from 1 to 5 and y values we gave the range is from 5 to 13. Here the difference is if you see that in x variable is 1 and here it is having in y variable 2. 5, 7, 9, 11, 13. So constant ratio in the entire range of the values. It means from 1 to 5 and 5 to 13. So then we'll say that that is linear correlation. That one only here we wrote. Thus for the unit change in the value of x, there is a constant change 2 in the corresponding values of y. So unit change in the sense here it is having only one difference. 1, 1, 1, 1 here and here it is having 2, 2, 2. Okay. So the variation between x and y is a straight line. If you keep it those points in this graph paper and by drawing that we'll get as a straight line. Okay. So straight line will get it. Keep it in all these points 1, 5, 2, 7, 3, 9, 4, 11 and 5, 13. All these points if you put it on a graph paper by drawing those all points and joining those points will get a straight line. Okay. And next, a correlation is said to be non-linear. So non-linear is nothing but what we said, or curvilinear if the amount of change in one variable does not vary a constant ratio. It means suppose change. Okay. For example, if rainfall is doubled, the production of rice would not necessarily be doubled. So so rain increased, but rice production of rice also not necessary to increase. Okay. These are coming under types of correlations. And next, methods of studying correlations. For studying correlation, we are using different methods. One is graphical method, another one is mathematical method. In graphical methods, we discuss our scatter diagram or scattergram or simple graph. Okay, no need of this. So this here it is. These are the important one. Mathematical methods we calculate here. So graphical methods in the sense by using graphs. Okay, and mathematical methods is nothing but by using mathematical formulas. Okay, the methods which are useful in mathematics. Then we are calling that as mathematical methods. In that, what we are using? Carl Pearson's coefficient of correlation, Spearman's rank coefficient of correlation, and method of least squares. Already we completed. This is in first part, curve fitting. So, and these are the two topics we'll discuss here. Carl Pearson's coefficient of correlation and Spearman's rank coefficient of correlation. These are the two topics we'll discuss, okay, in this particular unit, correlations. And next, regressions, another one. So here it is correlation coefficient. We have to find that. Simply we write it as coefficient of correlation or Carl Pearson's also. Okay, he has invented that. As a measure of degree of linear relationship between two variables, he developed a formula. That formula we are calling as correlation coefficient. For finding the correlation coefficient, this scientist called Pearson, he invented a formula. That formula simply we are calling as correlation coefficient, or in other words we are saying as Pearsonian coefficient of correlation or product moment correlation coefficient. Okay, so here generally we denoted this one by Rxy. Here x and y are two variables. So between two variables we are making a relationship between that, and that one we are denoting as Rxy. So these are the different formulas you see here.